Let's try a couple more advanced problems. But again, just keep in mind the idea still holds what we have to do, the steps we have to take. All right, so we're trying to add a bunch of rational expressions together. Well, it would be nice if they had all the same denominator. Unfortunately, they do not, so we're going to have to get a common denominator. Now, if we do this organized, my first step I would suggest is if there's any subtraction in the problem, turn it into addition. So we have a plus here, that's fine. Let's turn this minus into a plus, but we have to take the negative through. Now, one thing I will caution you on, when you do that one little step, when you take the negative through, if the numerator is a binomial, for example, that negative has to be distributed through. So let's just, for example, if this numerator was x plus 3 and there was a minus out here, I would have to make that minus x minus 3. That negative has to be distributed through. Now, thankfully, it's just a monomial, so we'll just make it the opposite. So positive 5 turned into a negative 5. But just remember that if you do take that negative, it must be distributed through to all terms in that numerator. Okay, so now we have one giant addition problem, but we still have the major issue of different denominators. We're going to need a least common denominator, and unlike the last problem that we did in that previous video, these are not all monomials. We are working with a monomial here, sure, but that's a binomial, and that's a binomial. So before we can figure out a least common denominator, we have to be looking at factors. So monomials, no worries. But binomials and trinomials, you have to factor those. So looking at the factors, how does x squared plus x factor? Well, pretty easy, but very important that you do that. Otherwise, the LCD is going to be very mysterious to us. Same thing here. How does 8x plus 8 factor? Easily. It factors into 8 GCF times the quantity x plus 1. I just write it underneath. Now you can compare factors for factors when you build up your least common denominator. So let's actually write it out, how we build this up. Now, here's the part that people don't want to do. You've got to take this very methodically, very slowly. You start with the monomials. Within the monomials, you start with the coefficients, the number part of the monomials. So here's what I'm talking about. 4x is a monomial. The monomial here in this denominator is x. The monomial here is 8. So start with, what is the LCD of 4x, x, and 8? Well, within monomials, you start with the coefficients like we did on the last problem. We have a 4, we have a 1, we have an 8. What is the smallest number that 4, 1, and 8 divide into? At GCF, the smallest number 4 divides into, 1 divides into, and 8 divides into. That smallest number is 8 itself. Right? Don't confuse this with greatest common factor. So 8, as far as the coefficients of the monomials are concerned, is the LCD. Okay, now consider the variables of the monomials. This has one factor of x. This has one factor of x. This has no factors of x. Well, the LCD has to accommodate the greatest number of factors, whether it's in common or not. So 8x is the LCD of all the monomial factors. Once you take care of the monomial factors, you move on to the binomial factors. This does not have any binomial factors. This has a factor of x plus 1. This has a factor of x plus 1. Again, what's the LCD have to do? It has to accommodate the most amount of factors, whether it's in common or not. So they both have one factor of x plus 1. So one factor of x plus 1 should do the trick. So my LCD for this particular problem is 8x times the quantity x plus 1. Right? Now, having established that, what I'm going to do is I'm going to write each fraction underneath the other, and next to it, I'm going to write the equivalent fraction. Each of them are going to have this as their denominator. So we'll write 3 over 4x underneath that. 2, now I'm not going to write x squared plus x, write its factored form. It'll be a lot more useful to us. So x times x plus 1. And then same thing here, don't forget it's negative 5 over its factored form, which is 8 times the quantity x plus 1. And then next to each of these, we're going to write their equivalent fractions that are all going to have this common denominator of 8x times the quantity x plus 1. So 8x times x plus 1. Okay. And then just like before, ask yourself what you have to multiply each denominator by to get the LCD. All right, so be real careful here. What do I have to multiply 4x by to get 8x times x plus 1? Well, definitely going to have to multiply it by 2 to start off with, and times an x plus 1. In other words, 2 times the quantity x plus 1. Right? Or we could say 2x plus 2. Distribute it through. So we have to multiply the 3 by 2x plus 2. 2 times the quantity x plus 1. Now, when you multiply 3, a monomial times a binomial, you're going to have to distribute. So 3 times 2x is 6x. 3 times 2 is 6. So the numerator of that becomes 6x plus 6. Okay, likewise here, a little bit easier. What do I have to multiply this denominator by to get the LCD? Looks like it's just missing a factor of 8. So multiply it by 8. Multiply the numerator by 8 as well. What do we get? We get 16. Okay, and then last one. What do we have to multiply this denominator by to get the LCD? Looks like just a factor of x. So multiply just a factor of x to the numerator, and we'll get negative 5 times x, negative 5x. Okay, all that's left to do now is to add our numerators together. We'll combine our like terms, the x's with x's, the constants with constants, clean it up, and see what we have. So if we start with the x's, we have a 6x, no x's there, minus 5x. 6x minus 5x is 1x. 6 plus 16 is 22, no constant there, so x plus 22. And then this will be all over our least common denominator, which is 8x times the quantity x plus 1. Something you don't want to do, don't distribute in the denominator. Right? You say, well, why did you distribute here? I needed to distribute in the numerator because I had to combine parts of my numerator together to get a finished product, this x plus 22. If I left it undistributed, the numerator would not be simplified. And we already said, just distributing through doesn't make it simpler. We distribute in order so we can simplify, but you're not going to be simplifying anything if you do distribute the 8x. It's not that it's wrong, it's unnecessary. In the numerator, you absolutely have to because you're going to be combining terms in the different fractions. In the denominator, there's really no point to it. And in fact, I strongly discourage you from doing that. So just leave this as your final answer. I mean, in the long run, it's less work. Okay, well, let's try this one. If I follow the steps, first thing I'm going to do is turn this subtraction into addition. Take the negative through that numerator. Next thing I'm going to do in order to see the LCD, I have to factor the denominators. So we'll call this x minus 5 times x plus 4. And this is the difference of two perfect squares, which factors into conjugates, x plus 5 times x minus 5. Okay, so now when I try to establish my LCD, we start with the monomials. Now in this case, what are we looking at? We're looking at 1 and 1. So as far as the monomials are concerned, the LCD is 1. On to the binomials. Well, this guy has one factor of x minus 5. This guy also has one factor of x minus 5. So 1x minus 5 covers them both. Well, this one unfortunately has an x plus 4. This one does not. The LCD has to accommodate all factors, all of them, even if it's not in common. So this one has an x plus 5 where this one doesn't. The x plus 5 has to come along for the LCD. So it looks pretty bad, but that is our least common denominator here. All right, so my next move is write one fraction underneath the other with the factored form of each denominator. So we'll call this x minus 5x plus 4. And this one we'll write negative 3 over, what do we got here, x plus 5 times x minus 5. Okay. And then next to these, write each of them with that least common denominator. Looks pretty bad, but it's actually not going to be too terrible when we do this problem. So I'm just copying my LCD. And then same thing, we got to do the same thing here. So x minus 5, x plus 4, and x plus 5. Okay, so what are going to be our equivalent fractions? Well, let's see. What do I have to multiply this denominator by to get the LCD? Well, if you take a look, this one is missing a factor of, what, x plus 5? So I guess that settles it. I have to multiply the denominator by x plus 5, so I multiply the numerator by x plus 5, and as I said in the last problem, you want to distribute this through. Don't leave it as 4x times x plus 5. You'll be very tempted to want to cancel common factors, which undoes all the work we're trying to accomplish here. So literally distribute 4x through x plus 5. You'll get 4x squared plus 20x. We do the same thing here. What do I have to multiply this denominator by to get the LCD? Well, it's missing a factor of x plus 4, so that settles it. X plus 4. Multiply x plus 4 to the numerator. Again, distributing will give us negative 3x minus 12. We distribute so we can combine like terms, which is what we're going to do in our next step. 4x squared, well, that's the only x squared term. We have 20x minus 3x is 17x. And we have negative 12, no other constants. And that's going to be over our LCD. X minus 5, x plus 4, x plus 5. And now there is one last step you want to check just to make sure that this is the final answer. And that is, you want to see if you can factor that numerator. Not only that, even if it factors, you got to make sure there's a factor common in the denominator. Otherwise, there's really no point. All right, so we're saying, is this rational expression simplified? Let me go out on a limb and say probably yes. I would say 95% of the time, your rational expression when you get to this stage is most likely simplified. There is a small chance that maybe there's a common factor, but don't waste too much time, stressing over this one because it's a bad one. It's a bad one to factor that guess and check method. But, you could have at it, but it's only going to work not just if it factors, but if it factors and there's a common factor of one of those in the numerator. And the only one that has a chance is that x plus 4 because 5 doesn't go into 12 and neither does negative 5. So you could try it out, but I'm pretty sure this one's done.